V4.3, Part A, size of the monthly repayment. Now, strictly speaking, this isn't examinable nor indeed testable, but it is instructional to work one of these through. We've got our interest, 9.5 divided by 12 divided by 100, giving me the 0.0079, etc. Number of payments, because we're doing this over 25 years, 300, and owing 300,000. Now, when you set this up algebraically, we've got 300,000 on the left-hand side, and that's equal to R lots of 1 minus 1.0079166667 to negative 300 divided by I. Now your calculator can handle that quite readily if we group this part together, and when you do the 1 minus etc. divided by the 0.00791667 etc., you end up with 300,000 is R times 114.456. Notice I'm keeping quite a few digits. Transposing that. Give me a repayment figure of 2621.09. Now I'll have to delete that in order to have room to do the second part. The second part, after 5 years, 300 is the total number of payments you had. 60 have occurred, you have 240 left. Now in part B, we write out the equation as before, only this time we want the principal remaining after 5 years. Now if we do that on the calculator, once again, if you want to see the whole thing, simply rotate to the side. We end up with $281,193.14. It doesn't appear to be much of a dent in the loan, but that's how housing loans work. Big at the beginning, you're mainly paying off interest for quite some time, then when the principal starts getting smaller, we get that cascading effect, but only in the later part of the loan. In part C, the halfway stage means that you've got 150 payments remaining, so you can plug and substitute into the equation as you did before. Neat little tool on your calculator, you can simply tab into the negative 240 area, delete back, and make that 150, and you'll see that we owe of the order of $229,636 at that stage. So the 229,636.56. Now you can answer D in quite a few ways. The key thing is that when you're dealing with a annuities and arrears case, your principal over time, or number of time payments, sees initially not a lot of principal paid off. You're mainly paying interest. They'll reach a few critical points where it will start to plummet. But halfway through the loan, that is not the case. You will still have quite a large principal remaining, so hence you'll be owing quite a bit of interest. In a moment, I'd like to quickly take you through how to find A using your graphics calculator. Setting up part A as a graphics calculator problem is the way in which we can be examined on it. So this is examinable in this instance via the GC only. And you'll notice that when I've set this up, 300, 9.5, 300,000, we've got the future value of 0. Payments per year, compounding per year, setting at the end because the interest is due for the first time at the end of the month when you've had the loan for 1 month. selecting the payment, and you'll see the 2621 and 9 cents that we had pretty much earlier in the problem. Now in part B, the scenario has changed. We want to find out what our present value of our loan is. We have 240 payments left, 95 interest, 2621.09. Now it doesn't really matter if I keep those digits there from the previous question. Future value 0, payments per year 12, and compounding at 12. And I'll quickly find that is the 281,193 we found earlier. And just make sure you write down the conditions, leaving the paper trail for the question.